Looking to buy cheap dual gear extruder for your 3D printer? Is it good? Is it bad? Is it worth your money? Let's find out! Hello, I'm Nikolai, and today we are looking at cheap dual gear extruder from China for about $5. At first sight, it looks like just a bunch of random parts in a Ziploc bag. There is no user manual whatsoever. Fortunately, it is not so difficult to figure out how to assemble it. But before we even start, we have to address some issues. One of the known issues is the idling gear chewing through the arm. Some people place washers to prevent that, but I think this will fix symptoms, not the issue. Anyway, I will use couple brass washers just in case. Another known issue is a machine screw that holds idler pulley in place. Some versions of such extruder have a fully threaded one, which is not suitable to be a bearing shaft at all. Some versions have a shoulder machine screw. Which one did I get? It is a shoulder one. Am I lucky? Not so fast. Machine screws are usually made from soft steel and are not heat treated. As a result, they are not suitable to be a bearing shaft. Another problem is the tolerances. Let's measure the screw. It is 2.9 mm, which is not an appropriate bearing shaft. It should be exactly 3 mm. As a result, gear fits too loosely on this screw. It can wiggle around, it can tilt, and this can cause all sorts of issues, including arm damage. Can we fix it? Sure. To fix it, we need a 3 mm hardened shaft. The easiest way to find one is to disassemble CD-DVD drive. This shaft exactly 3 mm, it's polished and hardened. But there is one problem. Because it's hardened, you cannot thread it using a die. Don't even try, your die will die. I will use my mini lathe that I converted into CNC to do that. By the way, if you like to see the conversion process, leave me a comment, click thumb up and subscribe to the channel. After the thread is cut, we need to cut the rod to the length and make a slot for a flat screwdriver. I did it with a Dremel. Unfortunately, there is another problem. The top hole in the arm is too loose. This should be addressed too. I fixed it using some brass and a lathe. Unfortunately, I don't have a footage of that. The result looks awesome. To assemble the arm, we have to grease the bearing outside since we don't want any lubrication on the shaft thread. Don't worry, when the gear spins, it will distribute grease around. Next, place the gear into the arm and push the shaft in. Don't forget the washers if you decide to use them, as I did. Use some thread locker on the arm thread and finally tighten the shaft. Now we can try to assemble the extruder. And we found another problem. The bushing for the arm holding screw is a loose fit and the arm can jiggle around. This is not good. A new bushing should be made. The outside diameter of the existing bushing is 5 mm. To find the inside diameter, we have to use pin gauges, but I don't have those, so I will use drill bits. It looks like 7/32 or about 5.5 mm fits almost perfectly, but only from one side. Luckily, it's easy to fix. Use a power drill. To make the new bushing, I will use my mini lathe again. Drill a 3 mm hole. Turn 14 mm length to 5.5 mm diameter. Turn another 6 mm to 8.2 mm diameter. And we're almost done. Cut it. And make a pocket for the screw head using an end mill. Finally, we can assemble the extruder. It looks pretty good now. Time to install it. And there is, yes, you guessed it, another problem. The screw is too short. Sure, maybe I didn't make the pocket for the screw head deep enough, but I don't think 1.5, maybe 2 mm will make much difference. There is a stiff spring and a lot of load on this arm, so I think it's still going to be short. The screw has to be replaced, which I did. A couple installation tips. Before tightening the gear on the stepper motor shaft, use a piece of filament to align both gears. Alignment is very important. Then, when tightening the stepper shaft gear, make sure the screw fits in the shaft cutout. It will prevent possible slippage. One more thing I did not particularly like about this extruder is that it bends the stepper motor shaft slightly. It happens because the gears are located too high on the shaft and it makes a long lever. I am pretty sure it is elastic deformation and should not cause any problems, but still, I doesn't like it. After installation, we have to change the number of steps per millimeters for the extruder. The original one on my Ender 3 has around 100 steps per millimeter. The Dual Gear Extruder needs around 140 steps per millimeter. Now to the tests. Thanks to Stefan from CNC Kitchen, we have awesome tool to test extruder performance. I did 2 tests for original extruder and for Dual Gear one. The original extruder at a rate of 10 mm squared per second is able to push 97% of requested amount of plastic. At 12 mm squared per second, the actual output drops more than 5%, which is not acceptable. Now for the dual gear one. It is able to push all requested filament at 10 mm squared per second. At 14 mm squared per second, it is able to push 97% of requested amount of plastic, and it drops 5% at a rate of 16 mm squared per second. Clearly, the dual gear extruder does a better job. However, it is not because the dual gear, it is because it has smaller gear, and a smaller gear provides more torque when pushing filament. I also printed extrusion consistency tower. Some people noticed weird extrusion artifacts on their prints with dual gear extruder. I did not notice any difference in mine. And now it's time to answer the question, should you buy one? If you have a lathe, sure, why not? It is a fun project after all. But if you don't have a lathe, it is a whole different story. I can't recommend such extruder in this case. If you like this video, hit the thumbs up button, leave a comment below and subscribe to the channel. Thanks for watching and see you next time. Bye.